Welcome to Spring LIB.
Okay, so we've got isopentyl acetate. So isopentyl. And what I'd like to do here is just point out our protons. Okay, so we've got 3 over here. Okay, we've got a couple here. Got a couple here. We've got 1 here. And we've got a couple there and there. And if I wanted to come and label these, I could say, I don't know, A. Let's get a better color. Let's call these A, B, C, D, and E. These are also E. Okay, and they're giving us an NMR, okay, ranging from 0.9 ppm all the way up to 4. Okay, so I'm going to call this 0. I'm going to call this 5. Okay, 1, 2, 3, 4. Okay, and let's see what kind of signals they're going to give us. Okay, so they say at 0.9, about 1, there's a 6 proton doublet. Okay. Okay, and at 1.5, there's a 2 proton multiplet. Okay, and at 1.7, there's a 1 proton multiplet. Okay, and at 2.0, there's a 3 proton singlet. Okay, and at 4.2, there's a 2 proton triplet. Okay, so now we can kind of easily assign these, right? We know, for example, well, there's only one set of 6 protons, that's E, right? So this has to be E, okay? There's only one single proton, right? That should be a pretty crazy multiplet, that's D, right? So this must be D, okay? As for A, right, we should expect that A should not have any splitting. Well, there's only one signal here that's not split, that's this singlet right here, so that's got to be A. And as for B and C, well, we can easily tell from the shift and the fact that this is a triplet, right, that B would have exactly 2 neighbors as B does here, so this must be B, and therefore this must be C by process of elimination. Okay, so if we want to look at the COSY, then we're just going to take this exact same sort of signal, okay, we'll go 0 to 5, okay, so we'll say this is 4, 3, 2, 1, okay, 0. Okay, and we're just going to mark on our COSY whenever the signal of 2 neighboring protons would be interacting, right? So, for example, let's start with A. Do we expect anything to interact with A? No, because A is off on its own. So this whole, column should have basically nothing in it, right? Let's contrast that with E. Does E have any neighbors? Well, it has a single neighbor, and that's D, right? So we would say, okay, D, which occurs at, let me copy down this, right? So we know there's okay, I'm just copying down this, but going top to bottom, and then I'm going to label them again. So the first one is E, second one is C, then D, then A, and then B. Okay, so the idea is that E interacts with D, right? So if we go to E and then we go down to D, right, at the confluence of D and E, we expect there to be interaction, right? Because these two protons talk to each other. And if they talk to each other, then they're going to have a signal at, X coordinate E and Y coordinate D on our COSY. And roughly it should have, in terms of its left and right shape, it should look like a doublet, right? But then in terms of its up and down shape, it should look like D, which in this case is like crazy because D is talking to all kinds of protons. It would be a septuplet, right? That the shape between E and D would be like a septuplet. Okay, so we'll just go down the list. Okay, now we look at, C. Who's C talking to? Well, C is talking to D, so we should expect a signal here, and we expect that C will be split into a doublet by D. Okay, right? And then C is also talking to B, right? And so we expect that B should be splitting C into a triplet, right? So we should get 1, 2, 3, like that. Okay. And then if we look at, move this over a little bit, a little better with where C is at. Okay. And then we move on to D, and we say, okay, who's D talking to? D's talking to E and C. Okay, so we say, okay, E, and E is splitting it into a septuplet, remember? But it split D into a doublet, right? So it should be basically the same thing, but, right, we're going to get a perfect reflection across this line. Is basically it. Okay, and then D is also talking to C, right? And so you should get basically the same shape, but reflected across the line. Sorry, I did that backwards. Right, it splits C into a doublet. Okay. Next, we're going to look at A. Okay, so A, who's A talking to? A is not talking to anyone, right? So we will get a signal at the confluence of A and A on this line, but that's it. Okay. In fact, everything talks with itself to some extent, right? So there's just like random, anywhere there's a signal, there's going to be a spot on the line, right? But we pretty much just ignore those because. Okay, so that's A. Finally, we look at B, and we know, okay, B was interacting with C, and it was being split into a triplet, right? Okay. And then we also say, okay, for C, look, that's reflected over here, right? Actually, there we go. Okay. That's basically it. Wow, it's kind of long, but hopefully you get the idea. That it's basically you just take the 1D NMR, you copy it up and down, and then anywhere that there's two signals that interact, you basically draw whatever the effect of that is on the plot at the point where they meet.